which decimal is larger. In this lesson, you will learn how to compare two decimals to the hundredths place by using fraction models. Let's take a minute to review place value. For this lesson, we'll be focusing on the place values to the right of the decimal point. Directly to the right of the decimal point is the tenths place. The tenths place indicates that the whole, 1, has been split into 10 pieces. A digit in this place indicates how many pieces of that size we have. So in this number, the 2 in the tenths place shows that we have 2 pieces of 1/10 size. To the right of the tenths place is the hundredths place. The hundredths place indicates that the same whole has been split into 100 pieces. So a digit in this place indicates how many pieces of that size we have. In this number, the 3 in the hundredths place shows that we have 3 pieces of 1/100th size. We read this number as 23 hundredths. Some decimals can be read using different denominators. Let's take 0.2 for example. One way to read this is 2/10 because it...
Think in your head or write down what fraction. How would we write 2/10 as a fraction? Okay. You should write 2 over 10, 2/10. Okay.
Represents 2 out of 10. We can also think of this decimal as being out of 100. So instead of 10 parts, let's divide our picture into 100 parts. We can see that we now have 20 parts shaded in. This decimal is 20 hundredths, which is written as 0.
Okay, so how would we write 20 hundredths as a fraction? Should look like this. So look, they're saying that 2/10 and 20 hundredths are the same. And if you look at the green part, they do look the same. The only difference is the hundredths pieces are smaller, okay? This is the same things as fractions that we used to do. So do you remember when we had 2/10 and we wanted to see what fraction would be equivalent? We said 10 times what gets us 100. And then if we multiply the bottom by 10, we multiply the top by 10. 2 times 10 is 20. And we said that 2/10 is the same thing as 20 hundredths. Remember that? Well, guess what? Same thing. 2/10 is equivalent to 20 hundredths. It's the same thing.
If we are comparing 19 hundredths...
Uh-oh, let me see it.
Think of this decimal, which is written as 0.20, to represent 5/10. We'll have 10 part models to help us compare. 3 over 10. We can rewrite 2/10 and 20 hundredths are two ways to represent the same amount. Here we're comparing the decimal numbers 5/10 and 3/10. We can rewrite 5/10 as the fraction 5 over 10 and 3/10 as the fraction...
What would you rather have? 5 cookies or 3 cookies? 5. So 5/10 is bigger than 3/10.
And 3 over 10. Let's use fraction models to help us compare. Our denominator is 10, which means we'll have 10 parts. Our numerator is 5, so we'll shade in 5 parts to represent 5/10. On the right side, we'll shade in 3 parts
So which one has the bigger green part? The 5.
To represent 3/10.
The alligator is going to want to eat the 5/10.
Greater than 3/10. A common misunderstanding is thinking that we can compare decimals that extend to different place values. Let's look at an example to see why this is incorrect. Here we're comparing 17 hundredths and 4/10. Some students may think that since 17 is greater than 4, then 17 hundredths is greater than 4/10. This is incorrect because we're comparing 17 out of 100 to 4 out of 10. We need to change the decimals so that they extend to the same...
Okay. So remember when I said, oh, so 5 cookies is bigger than 3 cookies. Well, that doesn't work when you've got a decimal that's in the hundredths and then this one's in the tenths, because you got to think about it differently. Remember, if it's in the hundredths place, it's cut up more than the tenths place. So if you get a problem like this, you can't just say that 17 is more, because it doesn't work that way.
So instead of 4 out of 10, let's think of it as 40 out of 100, which we write as 0.40. Now our decimals are both out of 100.
Okay, so what's easy is to make this 4 tenths be something over 100. And all we have to do is just add a 0 in the hundredths place to see that 4 tenths is the very same thing as 40 hundredths. So now we can think about it as cookies, because we both have numbers in the hundredths place. Would you rather have 40 cookies or 17 cookies? 40 if you're really hungry. 40 is bigger.
We can compare. 17 hundredths is less than 40 hundredths. Let's compare the decimal numbers 8 tenths and 15 hundredths. We can write 8 tenths.
Stop. Can we say, oh, 15's bigger, so 15 wins? No, we can't, because this 8 is in the tenths place, this 5 is in the hundredths place. We cannot compare tenths and hundredths that easily. We've got to do something.
Tenths as the fraction 8 over 10, and 15 hundredths as the fraction 15 over 100. Let's draw fraction models to represent 8 tenths and 15 hundredths. Remember that we have to have the same place value or denominator to compare two decimals. So let's think of 8 out of 10 as 80 out of 100, which we represent with a fraction 80 over 100, or 80 hundredths.
So it's easy to change this 8 tenths into hundredths, because if they are both in the hundredths place, then all we have to do is look at the bigger number. So 8 tenths is the same thing as 80 hundredths. So all we have to do is just put a 0 there in that hundredths place. Now which one's bigger, 80 or 15? 80 is the one that's bigger.
And on the right side we have 15 out of 100. So now we're comparing 80 hundredths and 15 hundredths, and we can see that 80 hundredths is greater than 15 hundredths. Let's look at one more example. Here we're comparing 3 and 16 hundredths to 3 and 61 hundredths.
Okay, we don't even have to change anything here because they're both in the hundredths place. So we've got 3 and 16 hundredths and 3 and 61 hundredths. Which one's bigger, 61 or 16? The 61's bigger, so it's going to be bigger.
Hundredths. The decimals have the same place value, so we know that the denominators will be the same when we rewrite them as fractions. 3 and 16 hundredths can be rewritten as the mixed number 3 and 16 over 100. 3 and 61 hundredths can be rewritten as 3 and 61 over 100. Since both numbers have 3 wholes, we really just have to compare the fractions 16 hundredths and 61 hundredths. Our whole is split into 100 squares, and we'll shade in 16 squares to represent 16 hundredths. On the right side, we'll shade in 61 squares.
So you
to
can see
represent
this is a
61
whole lot
hundredths.
more than
so
just
looking at our
16
pictures,
squares.
we can see that 16 hundredths is less than 61 hundredths, which means that 3 and 16 hundredths is less than 3 and 61 hundredths.
Okay. Each square is one whole, so we've got 75 hundredths and 8 tenths. They want to know which one's bigger. Just by looking at it, I can tell that this one's bigger because they both have 1, 2, 3, 4, 5, 6, 7 whole ones. See, 1, 2, 3, 4, 5, 6. Wait a minute. 1, 2, 3, 4, 5, 6, 7. They have 7 whole bars, but then on this one, it's only half. Where, this one has a whole nother one. So we know this one's more. Also, it's easy for me to think about, we've got 0.75, 0.8. I can't compare them like they are because this one has a number in the hundredths place where this one doesn't. All we have to do though is just add that 0. So now which one's bigger? 80 or 75? 80 is bigger. Where did I get 80 from? Well, because 8/10 is the same thing as 80/100. They're the same thing. Okay. Which one's bigger? 35/100 or 53/100? They are both in the hundredths place. So, which one would you rather have? 35 pieces or 53 pieces? 53. 53 is bigger. Okay. We've got some vocabulary practice. Okay. I'll sign in. Place value. Whole. Let's see what a whole is. A whole is all of an object. Place value is the value given to a digit by its position in a number. A fraction is a way to describe a part of a whole or a part of a group by using equal parts. When we compare, we decide if they are greater, less than, or equal to. Equivalent fractions are fractions that have the same value. Equivalent decimals are decimals that have the same value. 100th is the same thing as a fraction 100th. One of the equal parts when a whole is divided into 100. A tenth is the same thing as 1/10 as a fraction. It's one of the equal parts when a whole is divided into 10 equal parts. A decimal point is a dot separating the whole numbers from the fraction in a decimal notation. So those are some vocabulary words that you can look at. Okay, so it's your turn to practice. You're going to click on this link. And then it says to enter a code 152. See, 152 539. Miss Womack. Start game. Start. Oh. No, I don't want to just start. Says which one's true. All right, so we've got 300ths or 200ths. No, the 3 is going to be more than the 2. We've got 300ths or 2/10. Well, let's think about it. We've got 300ths. 2/10 is the same thing as what? 20/100ths. So if we have 300ths and 20/100ths, which one's bigger? The 20/100ths. So 20/100ths is the same thing as 0.2. So 0.2 is bigger. Got it. Okay, and so you're going to keep going like this. Now, if you go on decabk12.org, click 4th grade lessons, and then click this comparing decimal lesson, it's got the link in there. And then if you want to do optional resources, you can go on Khan Academy and do the lesson there. Okay, so let's look at our learning targets. So I can understand tenths and hundredths. Ready? Check, check, double check. I can read decimals. Check, check, double check. I can use models to compare two decimals in tenths and hundredths using greater than, less than, or equal symbols. Check, check, double check. Let me know if you need help. Have a great day. Bye.